All right. Welcome, everyone. My name is Iulian Dragos, and I'm working at TypeSafe. Thanks a lot for coming to my talk. I know it's 4 o'clock after 2 days of an awesome conference, I would say. I think it's the best one so far. What do you guys think? Yeah. All right. So I've been doing Scala for 10 years as well. So I don't know if you've seen 10 years of Scala, the performance from John Pretty and Miles Sabin. Awesome. So just before I start, I just wanted to show you, because even though my first email to the mailing list was quite a bit later, my first commit was this one on the Scala repo. So I need 3 more days to actually be able to claim I have 10 years of Scala. But what is funny is this. So the Scala compiler back then was called Socos. Socos compiled Scala. Recursive acronyms were all the rage 10 years ago. You know, so that's where we start. The code's terrible, so I'm not going to scroll down. I hope nobody sees it. All right. My talk today has 2 parts and a demo. So the first part is about the asynchronous debugger. And if you've been at Scala Exchange last December, you've seen probably a third of it, a third of what I'm going to show today. I've worked a bit more on it. But I definitely cannot cover 45 minutes. It's mostly going to be a demo and a few slides. So at the end of that part, I'm going to talk a bit about the Scala IDE for Eclipse, because this is what I'm doing as my day job at TypeSafe. I'm working on the Eclipse plugin for Scala. And there hasn't been a major release in quite a while, probably a bit more than a year. So I'm going to talk a bit about the latest milestone, our plans for the next few months and what we want to do. So feel free to leave at that point if you're not interested in Eclipse. I don't know, how many people are using Eclipse for Scala? Okay, well, about half. That's good. So I'll probably take questions in the middle, so before going to the Eclipse roadmap and so on. All right. So by now, probably most of you have an idea about what a reactive application is. I'm not going to go through the reactive traits and so on. But what's interesting for me is that you have an application with different logical threads. And that's all fine. But as programmers, we need to ensure that they coordinate and communicate somehow, because otherwise it would be just chaos. So the image I have in mind is some beautiful mechanism. I mean, a clock or a watch. Everything's perfectly fits together and moves together to give, I don't know, a measure of time or to produce some useful outcome. And what we often have is still a lot of gears, and they are still connected, but maybe they're not very well coordinated. And you know, as programmers, we have to solve this mess. I'm not going to say the mess is because of concurrency, but what we're having, or we used to have, are threads and locks. And luckily, we're moving away from them. So today we have futures and actors and parallel collections, and these are much nicer abstractions. They really make your code easier to write and understand, but what I'm going to show you is that it's a bit harder to debug, and what can we do about it? Non-blocking and callbacks. Yeah, this is what we get, essentially, when we try to not block. Blocking is bad, obviously, because you're consuming or holding a very precious resource, threads. They are quite expensive, OS threads. So you don't want to have them lying around, although maybe it makes your code easier to reason about to some extent. So what we're ending up with is callbacks and the fact that the flow of execution is not exactly following your program text. It's not as easy as before to know what gets executed when. It looks pretty similar. I love futures. Futures are really easy to use. The only thing is that, well, when I write this code and I'm saying, okay, retrieve all the tweets for a given user, execution jumps basically that line and goes to evaluate the number of tweets way before the tweets were retrieved. And what I'm doing here, I'm just chaining and I'm saying, well, whenever I have a value for those tweets, I don't know, retrieve their size, do something. So I'm going to chain futures. And my thread continues churning down and goes to the last line where it actually installs a handler for successful completion of a future. So this is all good. I think it's really easy to understand when you write this code. But if something goes wrong and you need to debug it, it becomes a little bit more problematic. So why is that? How do we debug in general, not necessarily asynchronous application? For me, it's really detective work. So what I'm usually doing, I'm starting with some undesirable effect. Something went wrong. I have a bug. And I can tell that because I see the output of my program, or I see that it crashed. So the first thing I do, I'm reasoning, and I'm trying to get back to the root causes. I'm sort of going back in my program execution, trying to see where did things go wrong the first time. I try to fix it, and then I continue. Another mode of operation when I debug is to just try to understand code by stepping through. Some people say that's not necessary, but I find myself doing it quite often. So what tools do we have to go back in time, or to find the source of an exception or the source of a bug? Well, we have the call stack, or we used to. In a sequential program, that's very nice because it records every method you enter. So basically, it's a path from the beginning of the program to the point where you either hit a breakpoint or crashed with an exception. Unfortunately, they are not so useful when you have futures, because as you can see here, this is the whole call stack. Most of it comes from the framework. It's Scala concurrent, or it might be akka, and some fork join frames. The top 3 frames are actually the same frame. It's just the way the Scala compiler compiles some code. It's simply a closure in which we entered. And if you actually click on those links, you get to the same line. So it's really empty. And that's a consequence of the way the flow of control and the call stack are disconnected. So can we recover it? And of course, the answer is yes, otherwise I wouldn't be here. It's pretty easy. Why don't we just record the call stack when a future is created? I mean, we're instantiating futures, and there is a call stack at that point. Why don't we do that in the debugger? So under the hood, what I'm going to show in the demo is simply sort of behind the scenes, intercepting all future instantiations and saving the call stack at that point. And when I say saving the call stack, I also mean local variable contents. It's a shallow copy of the whole thing. Then I resume the program. It's all behind the scenes. And when a breakpoint is hit and you're trying to step through, and you have local variables on the side, you can click on one of them. And if it happens to be a future, you're going to see the additional call stack there. And obviously, there's an overhead to doing that. I have some measurements, but I didn't put them on the slide. It's quite comparable with a conditional breakpoint in Java. And obviously, this depends on how deep your call stack is, but remember, they are pretty shallow. All of these computation steps run on a thread from a thread pool. So usually, you don't get to have a very deep call stack. And what's interesting is that Chrome does it for JavaScript already. I think this feature appeared in Chrome probably late summer last year or something like that. You see that they actually merged the frames. So here on this, I don't have a cursor. They basically append call stacks one below the other, and this means you only can follow one trace through your program, which is probably fine. In my prototype, if you have several futures in your frame, you can see each one of them where they came from. And Visual Studio does it as well. Just they don't call these things futures, they call them tasks. But it's exactly the same concept. So it must be good, right? Before I go to the demo, I just want to very quickly say that, well, when you debug actors, and I think a lot of people are using akka these days, you also want to know more or less the same thing. Where was this message sent? And actors are stateful. So state matters. You would like to probably know as well, not only where the message was sent, but what was the state when that message was sent. It might help you, debug. And this is really the same thing as for the future. And actually, this comes very handy, not only for message sends, futures, but also for play iteratees. And the starting point of this work was an email on the internal typesafe mailing list. I forgot now, I think it was James Roper who said, I have this iteratee that's diverging. I'm feeding it and the file, and it says I want more inputs. And I don't know exactly where this thing is coming from, and I can't really trace it back. So this is the prototype can actually handle that case as well, simply saving the call stack when different iteratees are created. And of course, this is all saved in a bounded buffer, so it might be that you don't have the information you're looking for. If your program creates hundreds of thousands of futures, you might eventually run out of memory, so then the oldest ones will just get lost, basically. Another thing now, instead of going backwards, is trying to understand and moving with the program or stepping. And when you have an actor, the equivalent of a method call, I would say arguably, is a message send, which is asynchronous. And I find it very useful when I debug to actually be able to follow the message and break when that particular message is received and see what that actor is doing with it. So what I call step with a bang, it simply means resuming the execution of the next message and breaking when that message arrives. But it's very hard to set such a breakpoint or step yourself because these things happen on different threads. And so far, I haven't seen a way in any Java debugger to step from one thread to another. Obviously, there are other messages that are exchanged in the meantime. Akka has a lot of system messages that go between actors, like heartbeat and so on. You don't care about those. Usually, you just want to see your own. So let's go to the demo. How do I do that? OK, so my first, can you guys see it? It's large enough? All right. It's not a lot of code. So in this example, I have just two actors that are sending messages to one another. So the first actor gets a start message and then starts sending numbers or integers to actor 2, who, if the number is below 10, increments and sends it back. And actor 1 again does the same thing, increments and sends it back to actor 2, until at some point actor 2 decides it's been enough and sends the stop message. So now, assuming I'm debugging and I see that my actor 1 is stopping, I'd like to know why this happened. So what I can do, oops, let's see. Oh no, this is the wrong example, sorry. All right. So what I have here on the top left, in the top left window, is the normal debugger window. I have a thread that stopped at a breakpoint. I have the call stack, which is very uninteresting. On the right side, here I have my local variables. And what's new is the asynchronous debugger window here, which is empty at this point. But if one of these values here happens to have some history and it's being sent as a message between actors, like this one, stop, I suddenly have this additional call stack. And everything that's grayed out is from the Scala or the Akka package. It doesn't mean there's any missing feature in there, but if I click on one of these, I just go to where this message was sent. And I see it was in actor 2. And I can do this again. This actor, in turn, received a number. So this one was 11. I can see where this guy was sent from, click on that, and I'm going back to actor 1. And if I had enough memory, I could actually follow, probably for this example, I can follow it all the way back to the start message. And what's interesting is that these are sort of live copies, so I can expand. If it's a complicated object structure, I can see its fields, and I can dig down and see what's in there. But the copy is shallow, so if somebody modified this value field, I would see the new value at the point I stopped in the program. Otherwise, it would be really too expensive. But you guys are all using immutable data, right? All right, so I can resume my program now. It doesn't make sense to look at anything else for the moment. Now let's do the other thing. Let's do the stepping. So my breakpoint is now in a different. Oh, you don't see the left side. Let me try to. OK. So I set a breakpoint at this line here. Just after the print line, I'm going to run my program again. And I guess you all know what happens if I'm stepping. I'll probably not get anywhere. I'll maybe go a few levels down inside of the Akka framework, but I will not see what happens to the message and where it gets delivered. So let's just press this button, the little bang, and notice that I got to the receive method in actor 2, and it's on a different thread, so this guy is a different thread. And if I go to my window, to my asynchronous debugger window, I can see that the message was sent from actor 1. I can even go back to that place, or I can continue. I can press again the bang button. I'm back to actor 1. I can see the message is now 4, right? So it's been incremented. I can do another step. And now I hit the breakpoint. Sorry, I should remove the breakpoint. I can do another step with the bang, and I ended up with integer, with number 5, and so on. So that's stepping. Another feature that I should probably use a different example. Let's just look at what happens if I open up this. This happens to be an actor or part of an actor. And what I have here is what I call logical structure. So normally, this is how the object looks. It has a $outer, it has a context, it has a self. It's pretty much not very nice. But if I enable this feature called logical structure, the debugger shows me some more information. So it shows me the parent actor. It happens to be hello aka/user, and it gives me the sender. And I don't know if you guys have debugged your aka applications in Eclipse, but sender is a method. So you wouldn't see it here at all, unless we had the evaluate expression, obviously. So sender is not a field. I can have it here. And the supervisor strategy, and I think these are actually objects themselves, so I can dig down and see what else is in there. OK, let me stop this one and talk about another feature. You know, in Java, when you have an error, like a null pointer exception, you can enable the debugger to stop, because you would probably want to fix it. It's a null pointer exception, it's not good. So it's a similar thing for an actor system is probably, to some extent, a message that ends up in dead letters. And aka actually logs these things on the console. If a message cannot be delivered because the actor died or something happened to the actor, it gets logged and it ends up in dead letters. So this little button here, the blue one, says break when a message arrives in dead letters. So if I enable that thing and my actors are going to do something wrong and send messages to a dead one, I'm going to hit a breakpoint. So let me open, I think it's this other example here. Here I have two actors that greet each other, and the receiver, after 5 greetings, just had enough. So he swallows the poison pill and dies. But this other guy doesn't know that, and I think I have somewhere scheduled every second send a greeter message. This guy will continue sending messages, and they will end up in dead letters. So let's run this thing. So these first 5 or 6 are going well, but now I have these log messages which say, message greeting from actor to actor was not delivered. Dead letters encountered. And after 10 of those, this thing stops. All right. So let's enable that feature. OK. Now it's enabled. I can remove this breakpoint, hopefully. And I resume. No, it didn't work. Whoops. It's a prototype. Let's try again. Nope, it doesn't want to work. OK. I think I know what it is, but I'm not going to debug it. Anyway, what would happen would be that I would hit a breakpoint inside the aka dead letter mailbox, and I could actually see who sent it. So let's get back to the slides. Those are much safer, right? Keynote doesn't crash that often. All right, so this is more or less what I showed you, the last parts, the logical structure of an actor and exception on dead letters. What could we do more? I thought these points of interest, places where you save the call stack, should be user extensible, because you might have your own asynchronous data structure and you would like to actually get this data collected in the debugger. But sometimes it's useful even if you don't have an asynchronous program. It works even in the Scala compiler, for example, when you have some big distance between the place where something gets modified and its effects. They are felt maybe 3 phases later. Somebody sets the wrong owner for a symbol, and then only at code generation phase you actually have the crash. But you would still like to know who set the wrong owner on that symbol. So that would be quite useful. The other aspect that could be improved is, well, fixing the bug for dead letters. But other than that, filtering the data that we collect. Probably you don't care about stack frames inside Scala or aka. So that memory could be better used in other ways. So to summarize, what I've shown so far are a couple of equivalents, loose equivalents of debugging tools that we have for sequential programs like the call stack and something for asynchronous program, which I call, well, in this case, the async stack, stepping with the message for stepping into exception breakpoints that are, break on a message arriving in dead letters, and the logical structure and actor details. Sorry, before I go on. So this thing is available in my GitHub repo. I didn't put out a binary release yet, mainly because I want to iron out some of these issues, like what you just seen during the demo. But I think some preview will be available in the coming months. So at this point, I'm going to take questions and then go on with a couple of words about the Scala ID for Eclipse 4.0. Okay, I don't know, fourth row.
How do you handle timeouts?
I disable them, yeah. That's a problem, indeed. Yeah.
In terms of usability and user expectation, would it make more sense to kind of fold this functionality into one step into function with maybe a toggle to say, do I want to go into Akka or do I actually want to follow my message along the execution path?
That's a good question. I don't know. We did something very similar for stepping into closures for the Scala debugger. So instead of stepping into map, it goes until you come back from map into the closure and you're one line below if you have, let's say, several lines of a filter or a map call. But I found it actually quite confusing, and people would like to have control whether they want to step into the method. Because map is clearly, yeah, you don't want to step inside map, but maybe you have your own resource, ARM sort of method with closable, and then you pass a closure. Maybe you want to go inside with closable. So that's why I thought it's nice to have two different shortcuts, but definitely that could be done, I guess. Yeah.
Follow-up question. Is this technology, is this concept something that could be abstracted away from the Eclipse debugger specifically?
Right.
Yeah,
so definitely this is not tied to Eclipse. It was just easiest for me to implement this prototype on top of Eclipse, but it's all based on the Java debug interface and Java protocols. So actually there are very little dependencies except the UI parts. Yeah, in the back. Right. So the suggestion was to have a filter on breakpoint saying I want to break only when this particular actor, based on the actor path. Yeah, that's a good suggestion. Thank you. Actually, I want to encourage you to suggest more things, and maybe if you find me over in the hallway, let me know if you think any of this is useful, and if you think something else much more useful should be added. I'd be very happy to work on that. All right. If there are no more questions, then I'm going to talk maybe for about 10 minutes about Scala ID for Eclipse and what's going to happen next. So the next release is codenamed Lithium, and it's been in development for a while. The reason is, well, it's a lot of work, and second, we've been working on play support for a while, and then we came back to the core, and it's a long way to the top, and these people here, they know that very well. One of the features that we added, it's more of a performance tweak, which is called quiescence type checking, and I'm going to have a slide about it, but in principle, this greatly reduces the rate, the allocation rate for the IDE when you're typing. A couple of quick fixes. Some of them come from the community. Some of them we did ourselves, like implementing abstract member. This is also something that it's very nice to have, right? So if you're extending a Java interface or even a Scala trait, you want to be able to quickly have a method stub for that thing. Maybe one of the biggest things we've done, and it's just part of Milestone 2 release last week, it's multiple Scala version support. So what does this mean? Until now, the Eclipse plugin for Scala was tied to a specific Scala version. So if you were using Scala 2.10, you needed to download the plugin for 2.10, and the same for 2.11. That's no longer necessary. So what we do now is we ship a 2.11 build of the IDE that can actually build your 2.10 projects too. I'm going to talk about how we do that a little bit later. But I think this is quite impressive because you can finally have a workspace with, you're not forced to upgrade all your workspace, all your projects at the same time, if you're using the IDE, obviously. We also integrated a bit better the SPT incremental compiler. So the latest developments there, like name hashing, make it much smarter about what it needs to recompile. So this release cuts down on compilation times, and it's quite nice. So I think if you're using SBT 0.13.5, you already have the feature. We also have it in the milestone. And the last thing we've been working on is a stable API for plugin writers. We want to sort of divide a bit the work between the core, more stable Scala IDE and plugins that come on top of that. And for example, Scala Test, I don't know if Bill is in the room, but they've built probably the first IDE plugin on top of Scala Core. And they've been very responsive, and every time we released a new version, because it was binary incompatible, they re-released their Scala Test plugin. So we want to be a little bit more considerate of their time and offer a binary compatible API. So people can build other stuff on top of our stuff. We're a pretty small team at TypeSafe working on the IDE, so we really depend on community support. And we're lucky to have some very, very good people helping us, and we have a number of features that come from the community, and the biggest one, and I think this is going to be huge, is evaluate expression in the debugger. So there's an open pull request with about 10,000 lines of code in there. Half of that is probably tests. And it seems to be working very well. So we're working now on reviewing that, and it's going to be there very soon. We also had some debugger improvements, refactoring, new refactorings. They all come from the community. So nobody on the Scala or IDE team really worked on refactoring in the past few years. It's all done by community, which is great. Of course, there are a ton of UI cleanups, wizard hovers, completions are much better now. And I really encourage you to give it a try and, give us feedback. But now back to quiescence and type checking. What you see here it's a very scientific study of me typing for about 10 seconds and looking at how the heap varies, how it moves. And what you see on the left is the current stable release. What you see on the right is the milestone. So what we do actually when you're typing, we tell the type checker, come on, the source code has changed. Please give me all the errors. And then it starts. But obviously, it cannot finish before you type the second character because you're a fast typer. So then it says, oh, I have to cancel that, throws an exception, rewinds the stack, and starts type checking again. So what you see here are basically parsing, allocating an AST, and dropping it, and doing that again. So obviously, that's not very, how should I put it? That's not very efficient, not very nice to your garbage collector, but it gives you very fast errors. So the moment you stop typing, you already gain some time. So you'll get the errors quickly. But we thought maybe that's not such a good idea, especially if you're on a laptop and you don't have that much memory or you don't have that much battery life to do that. So right now we're actually waiting for, I think, 500 milliseconds of quiescence. So stop typing for 500 milliseconds and only then the compiler will pick it up. I think it's a pretty big difference in how it feels. Temperature-wise also. And the multiple Scala version support. So because we are embedding the Scala compiler inside the plugin, which is maybe the main difference between us and IntelliJ, we have this very hard dependency on compiler internals. So we have the compiler at our fingertips, and we really put our hands up to shoulders inside the compiler to get all the information we can get from the compiler. But this also means we're so tightly coupled that we can't really swap versions without actually, rewriting some of our code. So what we did was working with the Scala team on adding a compatibility mode in the Scala compiler. So now there's a new flag called source, X source, and you say, I want you to be in 2.10 compatibility mode, and then 2.11 will start issuing the errors it used to do in 2.10. So, and moreover, it can accept class paths with 2.10 compiled binaries. The Scala 2.10 library, everything underscore 2.10 will just work fine. But when we build, we just forget about this flag because the flag is really only about the type checker. Maybe the compiler might be able to generate some code, but I don't think it's intended to be used that way. So for building, we're really using a 210 compiler. So build errors will be exactly the 210 errors, and the bytecode and everything will be just 210. And actually, one of the demos was using this feature, so it was using aka for 210, even though everything is 211 on my machine. So it seems to work, but I encourage you to try it out and let us know of issues if you see any issues, because for 4.0, which should be out in a few months, we don't want to build a 210 release anymore. So if there are serious issues, we should know about them and fix them. Otherwise, there won't be a 210 version of 4.0. Okay, so what happens next? So I mentioned that we want to release the core, the update, the 4.0 release. We want to give that out to you end of the summer. What we'll be working on next? So one thing is the SBT server, and this is actually a shared work with the SBT team. The idea is to have a full SBT process to which we delegate building. Right now, we actually take the incremental compiler from SBT and then we drive it inside Eclipse. You don't need to install SBT or anything. We want to change that, at least as an option, because we cannot build complicated projects this way. We know how to build Scala sources, but we have no idea how to build less or CoffeeScript or whatever else you can have in your Play application. For that, we need SBT. But also, you don't want to have so many SBT, servers or instances running, so we want to share that. And SBT server is sort of a joint project with Activator and SBT, and having SBT act as a server that serves requests. You say, build my project, give me your class path, launch in debug mode, launch in run mode, and so on. So that's gonna happen by the end of the year, and we're gonna have also the ability to import an SBT project immediately. You will not be required to do SBT Eclipse export, basically generating your Eclipse project files every time you do a change in your class path on the SBT side. There's also a very promising Google Summer of Code project. I don't know if Simon is here, Simon Scheffer. He's a very, very productive contributor, and he's working on a very cool feature, I would say. It's called Extensible IDE. And the whole idea is, why don't we use Scala snippets to customize the editor or some parts of your IDE? I mean, Emacs has been doing that for 50, I don't know, maybe not 50, but 25 years. And it works well. And Scala has a toolbox compiler and a REPL, so there's really no technical reason why we couldn't be doing that. So his goal is to have save actions, for example. It's very bad style to commit anything on GitHub with whitespace at the end of the line, or you'll be forever mocked by your colleagues. So why not have this automated? And why should we, build in this feature when we could have a very small snippet that just filters your document and removes whitespace at the end, trims to the right or whatever. Another thing would be when you're debugging and you have some objects, usually you see toString. That's what we display in the detail window. But why should it be toString? Why shouldn't it be something more complicated? And why shouldn't that be another Scala snippet? You can just type yourself and that's it. Or auto edits. Whenever you press enter, for example, you want to, I don't know, indent in a different way if you're inside, I don't know, your custom method or something. So all of these things would be possible, and I think Simon is doing great progress, and I'm really looking forward to seeing this. And just before I go, that's the peak where we want to get. I think we're a little bit lower than where this picture was taken, but we need your help. So please contribute. I think it's much easier than it sounds. We had a couple of people just getting started, and they issued their pull request in a matter of days after the first email on the mailing list. So it's possible, and we'd be very happy to work with you and get you started. Thank you very much. If there are no questions, then let's go for a coffee.